Hi, and welcome to another video on object-oriented programming in C#. With me, Marinas Toman. Okay, so in this video we're going to talk about polymorphism in C#. And polymorphism is a very important concept in object-oriented programming. So we'll look and see what does Microsoft say. So polymorphism is often referred to as the third pillar of object-oriented programming, after encapsulation and inheritance. Polymorphism is a Greek word that means many-shaped, and it has two distinct aspects. So at runtime, objects of a derived class may be treated as objects of a base class in places such as method parameters and collections or arrays. When polymorphism occurs, the object's declared type is no longer identical to its runtime type. We'll look at what this means in an example. Base classes may define and implement virtual methods, and derived or children classes can override them, which means they provide their own definition and implementation. So at runtime, when client code calls the method, the CLR looks up the runtime type of the object and invokes that override of the virtual method. And in your source code you can call a method on a base class and cause a derived class version of the method to be executed. So I know that's a lot of words, but we'll see this in practice. So W3 schools, something similar. Polymorphism means many forms, and it occurs when we have many classes that are related to each other by inheritance. So, like specified in the previous chapter, inheritance lets us inherit fields and methods from another class. Polymorphism uses those methods to perform different tasks, and this allows us to perform a single action in different ways. So we'll see really, how powerful this can be. And really why do we care about polymorphism. And so this is really very closely related to inheritance and abstraction. So the best way to learn this stuff, as usual, is just to go through an example. So for this example, think of a base class called animal that has a method called animal sound, and derived classes of animals could be pigs, cats, dogs, birds. And they also have their own implementation of animal sound. So the pig oinks, the cat meows, etc. The dog barks. So this is what that would look like if we had our base class animal and just had all it has is an animal sound, and then pig extends. So this is a child class, and it has its own, the pig says wee wee, and then again the dog, and it has its own implementation. So each implementation is different. So this basically is just us extending. So that's our base class. This is a child of animal, and this is a child of animal. So when we create the pig and dog objects and call the animal sound method on both of them, so this is our code that we had up until now. So now in another program, what we could do is we can use now this. We could say animal and just create new animal. That's okay. This is really the new part here. So we could have an animal that is a specific. So this is the parent class, but we can create the type of a child class and store it into the parent class. Okay, and then the same here again, we can do that, and then these are all valid then, because these method calls, because as far as the compiler is concerned now, these are animals, and this does belong in does exist in the animal class. So, but basically at runtime, what happens is it's going to open up and realize this isn't an animal. So if we look at this, you can see it's actually just calling the animal method every time. Okay, so that's a problem. Remember what we said in the previous video about if we're extending from a class and we want to implement our own method, or our own version. So this is the output from the example above was probably not what you expected. That's because the base class overrides the derived class when they share the same name. So C# provides an option to override the base class method by adding the virtual keyword to the method instead, or inside the base class, and by using the override keyword. So in this example here, we can see we have added this virtual keyword, okay, to the method in the base class, and then we're saying as well in the children classes that we're overriding. We actually want to change. We don't want you to, use this method. We want to use our own, version of the method. So now when we try this, you can see, it picks the specific instance of each method. But now we can see that, I could have a list of animals and then I could create different types of animals as long as they extended from the animal class. Okay, so as long as they are of type animal, pig is a animal, dog is a animal. So as long as they are all the same type, then I can store them all in the same list. And only at runtime then does, these all look, you could imagine now that this could be in a loop, and I would just have one line, and that would be calling the same method, but every time that it was called, depending on what, is inside this type. So at runtime, it'll basically be, the compiler will open it up and say, oh, okay, you're a specific type of an animal, and then it basically goes down and looks, okay, I can see now that you're, you have your own kind of implementation of this method, so then that's what I'm going to call. So this is kind of where we get the name from. An object can take many different shapes. So you can see now this one method call from this one type now produces 3 different outputs, because we have 3 different classes. So this is why and when would we use inheritance polymorphism. So again, it's good for code reusability and to reuse fields, and it's to make code less complex as well. It's to make it easier to work with. So back over to Microsoft, they go through, again, a more comprehensive example, and then they even talk about the virtual members and everything. So you can have virtual properties as well, virtual methods, and then you come down into your derived class and you just use the override keyword to put in your own implementation of it. And then we can prevent class from overriding virtual members and access base class virtual members from derived classes. So that's the just using that keyword. So you can go over to Microsoft themselves and see what they have to say about it. And again, I would always go to one of these chatbots and see if you're having trouble kind of understanding what all of the complex some of these concepts are really complex. So if you're having trouble to comprehending it, sometimes it's a good idea just to go and see what these things have to say. But this is Google Bard, and what do they say about polymorphism? So polymorphism is the ability of an object to take on multiple forms. This is achieved through the use of abstract classes and interfaces. An abstract class is a class that cannot be instantiated, but can be used as a base class for other classes. And an interface is a contract that defines the methods that a class must implement. So we look at interfaces in another video as well. So an example of polymorphism, you could have an abstract class called animal that defines the method speak. You could then create two concrete classes, dog and cat. The dog cat would implement the speak method by barking. The cat class would implement the speak method by meowing. The speak method is polymorphic because it can take on different forms depending on the type of object that is calling it. In this case, the speak method can take on two forms. So that's really what we're showing here, that this animal sound method had three different forms. But they all come from the same type, and it's the compiler that's doing all the work at runtime. It's cracking these objects open and saying what is inside, and then it's able to run to go and look at the correct place in your class library to see where the correct method is. So this is something that's very powerful that we're going to be able to use, and you can see how this will make our algorithms, and even when we're accessing and we're using different data structures, you can see how this now can become more powerful when we can start to use all of these concepts together: inheritance, abstraction, polymorphism, and encapsulation as well. Okay, so that's everything for the video. Thanks for watching.